Hey guys, we've made a few changes lately to the firmware and to the diabase printing wizard, so I thought I'd do a quick video here just to catch you up on what's new. So to start with, you want to make sure that you have the latest version of firmware installed. So if you come in here to your settings and general, here you can check your firmware version. You can see here I have 2.04 RC2 installed. So if we go to the diabase website, then under support, the H-Series manual, we can come down to electronics, and here, upgrading firmware, you'll find a link to GitHub, and there you can find the latest release. As you can see, it's 2.04 RC2, so I am up to date. If I wasn't up to date though, I would click on this link and then come down and download this firmware zip file and the web control zip file. And then I would come back to my controller and come back to our settings, upload files, then go and find those files in my downloads folder. And then the same thing for the firmware. For the diabase printing wizard, you can see here I've got version 1.0.2 installed. So again, if we go to support, then H-Series manual, and come down to software, diabase print wizard, you'll find a link there for the latest release on GitHub. Same deal. Download the setup.msi. In this case, though, you will need to uninstall the old version of the post-processor before you install the new one. Okay, so let's talk about what's new. So most of the changes that we've made are in this Offsets tab. And if it's been a while since you've updated your firmware, this will look quite a bit different. Just to start with, kind of from top to bottom, we took away the Find Center of Cavity buttons that we used to probe either the hollow cylinder that we printed to get our XY offsets or the milled pocket. So instead of having a button for every tool, which didn't make a lot of sense, we moved all of our probing buttons down into this region. So we still have the set XY for each of the tools. So after you probe the center of the cavity, when you print that offset cylinder, then you can hit set XY and it would update those offsets, or the same thing for a milling tool. So we also added the ability to change the value of the adjustment buttons that you have for your offsets. And that's really nice. Before, when you wanted to change the value of a tool offset by, say, 15 millimeters, you needed to actually click on the value, type it in. Otherwise, you'd be hitting the button 1,500 times. So it's just a much easier interface here. Then in this probe workpiece region, we've got our directional probing. So probe in X positive, X negative, probe in Y positive, Y negative, and probe down in Z. And then this Find Center of Cavity button is the same that we used before to probe the tool offset cylinders. This is new, so I'm going to show you the function of the touch-off plate here today. So this button, touch off Z, will send the machine down in Z until the touch-off plate is triggered. So we'll look at that in a bit. And then down here in the workplace coordinate offsets section, we've added your A and C axes. So this is really handy for your rotary axis setups. So say you've got a fourth axis setup, and in G54 mode, you're working on one side of your part. If in G55, if you set that to 180 degrees, you could easily just activate G55 mode. It would flip the part over, and you could work on the opposite side of the part. And then one more thing that's new on this page is this show jog buttons. And I think this is accessible on any tab. So the nice thing here is when you're in your offsets page and you're probing to find the corner of a piece of stock or the center of a cavity, it's really nice to not have to go back to your machine control to get your jog buttons. you can just instead scroll up to the top of the page, show these jog buttons, move the machine around, and then continue on. Okay, so let's talk in a little bit more detail about some of this functionality, starting with the touch plate. So this is the tool setter that we've developed for the H-Series. We're using it right now just as a touch plate, but it is very similar to our omnidirectional probe in that you can trigger it from any direction. Right now, though, we're just going to be using it to set our Z offsets. There are thumb screws that come with the unit, and there are a series of holes in it, and those are to enable mounting it on different setups. So right now I've got our standard print bed installed, but you can also mount it in the Dovetail Bed in multiple locations or on the vices or fixturing blocks that mount in the Dovetail Bed. So to start with here, I'm just going to install it on the print bed. Now there are 5 different locations where I could install it. I'm just going to choose the far left one, just using these 2 M3 thumb screws, and I'll install it with the cable coming out to the left-hand side. And if this is the first time you're installing it, you'll also plug a cable into the bottom left corner of the base casting. There's a connector there. The touch probe will come with 2 cables, one to go from that connector to the connector on the cable that's attached to the probe. So we'll connect this. Then we'll come into our controller and bring up our probe. And now we'll jog the machine over until we're just above the touch plate. So we want to bring it down in Z. And we want to bring it down carefully. So I mentioned this in a couple of the videos already, but when you're working with this machine, it's going to listen to what you tell it to do. So if you click the wrong button, it will drive the probe or a tool down into your setup, and it can harm components of the machine. The machine is built to have certain failure points so that, say, if you run an extruder down into the bed, the heat break is what's going to fail first, not one of the components of the motion control system. And the same thing with your cutting tools. In general, you're going to knock a spindle out of tram and you're going to break your cutting tool, but you're not actually going to damage the machine itself. You might damage your print bed or a vise or the part that you're working on, but in general, the machine's fairly tolerant to crashes. So anyway, we do want to avoid crashes as best we can now. So when you're jogging the machine, you want to use the smaller movement buttons most of the time. So I'm coming down toward my touch plate now, just above it. And now the probing cycle that we're going to run when we come into our offsets page is this touch off Z. So what we're trying to do here is establish the top plane of the touch plate in reference to our probe, because all of the tool offsets are defined based on the tip of the probe. That endpoint of the probe is our kind of our 0, 0, 0 point for all of our tool offsets. So this first step is just touching the probe down to the top of the touch plate. So I'll hit go here. And then our Z value, we can see, is 28.49. So that's the height that we are above the surface of the bed. So the machine was already home before I started this. So from the bed surface up to the top of the touch plate, that's that measured value. So what we want to do now is come down to one of our other work coordinate systems. And I like to use this G59.3 as my tool setting coordinate system. You can choose any of them, but this one is the last that I would choose in any of my setups, so I might as well make use of it for measurement. So I've already got my X value stored as this -136 value, so that I can quickly come back to this position if I need to recheck my tool offsets. Say I swap out cutters and my spindles. And then my Z value is 28.5. Right. So that was the last time that I set this up. So we're pretty close to that already, 28.49. So we can just type that in here and activate this coordinate system. And now you can see my X, Y, and Z are all 0. Okay, so now I have the top plane of the touch plate set to Z0. I can come up in Z. So let me show these jog buttons. Come up 50. And then bring up spindle 1. And I'll come down in Z. Oops. I'm not going to just hit Z negative 50 though, because I don't know that I have the correct offset already defined for this tool. So I'll come down, I can see 25 is going to be fine, then I'll come down 5 at a time in Z until I need to be within 10 millimeters of the top of the touch plate in order for the cycle to work. So this touch off Z command is going to bring down the tool until it either makes contact with the touch plate or it moves 10 millimeters, whichever comes first. So I'll hit touch off Z. And you can see I already had my Z offset for this tool set. So again, I'll come up in Z. I'll bring up spindle 2. And in this case, let me just change this value so that we actually are setting our offset. So now I'll come back down in Z, just 5 millimeters at a time, till I'm within 10 from the top of the touch plate. Then I'll say touch off Z. And now we're at Z 9.19, so we know we need to change our offset for this tool. So what I like to do is just click on that value, change it to 0, and so the value that shows now is what I need to enter as my offset, but the negative of that value. So tool offsets are a little bit less intuitive than work offsets. So the way to think about a tool offset is with my probe in a particular position, if I bring up the tool, where is the endpoint of that tool, the center line endpoint of the tool with respect to where the probe was? So in this case, from where that endpoint of the probe was, the endpoint of this tool is down 14.19 millimeters. Okay, and then one more time, I'll come up in Z and call up spindle 3. And then I'll jog down. And it's worth noting that if you don't have your X and Y offsets for your tools already set, you will need to jog the tool around an XY to make sure it's centered over the touch plate before you run this cycle. So in this case, touch off Z. And again, I already had this tool set. Let's just check our repeatability once though. So let's bring this back up and then come back down and touch off Z again. And you can see we're still at 0. So it seems to be working well. When you're dealing with multi-tool processes, your offsets are critical. And the X and Y offsets are a bit of a pain because you have to either print or mill a feature and then probe the inside of that feature in order to get the location of your tool. But you shouldn't have to do that very frequently. Unless you crash the machine or you run into maintenance trouble, you have to switch out a clogged nozzle or something, you generally don't have to mess with your X and Y offsets. Your Z offsets, though, at least on your cutters, you do often have to change because you're going to be swapping in and out cutting tools. So this touch plate just makes that a whole lot easier. And one more quick note, before you go to run a print or a milling cycle, you want to come back down to your work coordinate offsets and make sure that you have the coordinate system that you want to be in active. And along these lines, in your starting scripts in Simplify, you probably want to add a G54. So generally, when you're printing with a flatbed, you're just going to want to be in G54 mode. So that'll be X, Y, and Z offsets of 0. And then when you're not working with a standard flat print bed, you can come in and modify your processes. But for so many of your prints, you're going to be working with the standard print bed. So you might as well have this code in all of your processes to begin with. And then you can just come in here and comment it out when you're not using that standard setup. Okay, let's switch over now from the standard flat print bed to the dovetail bed. I have a quick milling job, and I want to show using the touch probe on the machine to find the edge of a piece of stock. So I'll just flip the magnetic latches here, take the standard print bed off, and install the dovetail bed. So when you're going to put either of the beds in place, you want to make sure that the tapered pins are toward the front. They fit into the tapered holes on the bed support. And this is the component that I had machined at an outside shop, and I just forgot to put a counterboard and drilled hole in the top section here. Now this is an aluminum part. If you have a machine before serial number 30, make sure you contact us before you do any machining of metals or any abrasive materials. We now have a guard to protect the ball screws from any chips, and metal chips in general or abrasive chips we really want to keep off of the ball screws to prolong their life. So please contact us and we'll get you set up with this chip guard. What you also want to do is plug all these fixturing holes in the dovetail bed with set screws so that chips don't fall through there as well. Okay, so I have a standard vise installed. We will do a video on all the different setups that you can do with the dovetail bed. Right now I have one of the simplest setups, which is just one fixed jaw mounted in the center dovetail and then one active jaw. So I'm going to mount my part in here. And I've got the screws that are holding the vise, the M3 screws that are holding the vise into the dovetail, torqued to about 10 inch-pounds, and I'll torque this M4 screw to about 12 inch-pounds in that range. Okay, so I have the part clamped in my vise, but I don't know where it is in the coordinate system of the machine. So I'm going to use the probe to find it. First thing I'll do is jog the machine over so that the probe is over top of the part. Okay, so one thing that you want to watch out for now is when you're probing a workpiece that is not just a flat surface, you have to watch out for the other tools on the machine and make sure that they're not going to interfere. So you can see on tool 1 here, I'm going to have a close clearance with the top of the part over on this side. So I'm just going to keep an eye on that as I bring the machine down and make sure that I don't interfere with the part and crash that tool into it. Okay, so it looks like I'll be fine on clearance. So I'll come into my offsets page and then come down here to my probe workpiece section, and then I'll probe down in Z. And now I have to choose which workspace I'm going to use for this job. So I'm going to go with G55 here and set my Z value to what I just probed, so 25.81. And now you'll see that the Z value didn't change here because I don't have this G55 workspace active yet. You can see here this check mark is showing me that I'm in G54 mode. So if I switch over to G55, then you can see my Z value is now 0. So let me go back to G54. And now I'll come up in Z off my part. Then I'll come over to the left side and make sure I'm off of the edge of the part. Then I'll come down in Z. And this is where I really want to watch that other tool to make sure that I'm not going to make contact with the part. Looks good there. And so now I'll come back to my offsets and probe in X positive. And my X value is negative 49.37. But I have to take into account the radius of the probe. This is a 2 millimeter stylus on this probe. So my radius is 1. So I need to think about which side of the part that I'm on. Since I'm on the left-hand side, I'm further in the negative direction by 1 millimeter than the actual edge of the part. So instead of negative 49.37, the edge of my part is actually at negative 48.37. So I'm going to set that as my G55 X offset. So, and again, just to double check, let me go into G55 mode, and I'm at X of negative 1. I can stay in this mode while I'm doing this probing. There's no reason really to be switching back and forth. Sometimes you'll want to know what your coordinate values are in reference, but for now, I'll just stay in G55 mode, go back to my machine control, come off of my part. Now again, this is where we want to be very careful what button we're hitting since we're in contact with the part. If we were to go in X positive now, we would bend the stylus of the probe, and then we'd have to reinstall a new stylus and redo all of our offsets because, again, the probe is our 0, 0, 0 reference. So if we knock that out of whack, everything that's referenced to it is now unknown. So again, very carefully come off the part, and now we'll come negative in Y. And then positive in X to come beside the part on the bottom, or on the Y negative side. And now we will probe in Y positive. And again, same situation, we're at negative 39.2, so the edge of our part is actually at negative 38.2. Then we'll come up in Z above the part. And now we can just type in here G1 XY, which is saying move to X0, Y0. And so now we can check that the probe is actually aligned with the part in both directions. That looks good. Now I did have to swap out a couple of cutters for this job. So I'm going to reinstall the touch plate. And in this case, it will go on the vise, or it could go in any of these locations on the dovetail bed. But in this case, I'm going to install it on the fixed jaw of the vise. For that, it takes M4 thumb screws rather than the M3 thumb screws that we used on the standard print bed. So these are the same thumb screws that we used to level the bed, so you'll already have them with the machine. Okay, so I'll jog the machine over top of the touch plate. And I'll come into my offsets page, and I'm going to activate my G59.3. These values are going to change. The X and Y values don't really matter for this process. You'll just want to set them if you're going to be coming back to the same location to use the touch plate again and again. Okay, so I've got my Z offsets set now for my new tools, and I want to get the touch plate out of the way. It is a sensitive device, so we want to keep it away from the chips that we'll create with our milling cycle. So I'll take it off here with these thumb screws. And then I'll unplug the connector and get it out of the way. Okay, so let's open this part in Fusion, and you can see here I've already got this set up. So we have our origin at the corner of the stock that we probed, And then I've got these 3 operations. So a drilling cycle, pocket mill, and then a chamfer to break that edge. So we should be good to go. Let's post-process this file. And then we'll come into our controller and upload that G-code file. And then I'm going to come over to my job status tab, turn my speed way down, and then come back to my G-code files. So it should switch to G55 mode. So we want to have our hand on the E-stop, and here we go. All right, this has just been a quick video on what's new in the firmware and on using the touch plate to set tool offsets and using the probe to do a little edge finding. If you have any questions or comments, please let us know in the forums at diabasemachines.com, and we'll see you in the next video.